Alright guys, today is the third and final method for solving systems. So we've already looked at graphing and substitution, and today we're going to look at how to solve a system of equations using elimination. So our essential question is, how do you solve systems of equations using the elimination method? So before we get into the lesson, we need to know what the elimination method is. It is another method for solving systems of equations by adding or subtracting to eliminate a variable. So previously I just asked you what it meant to eliminate something, and hopefully you said something along the lines of to get rid of. We need to make something cancel out here. That's going to be our big goal. So some steps to doing that. Step one, we've got to make sure the equations are lined up. So just like when you're adding numbers and you have, like, say you had 234 plus 57, we've got the ones lined up, the hundreds lined up, and the tens lined up, all of that good stuff. Our equations have to be lined up. And what I mean by that is you have to have your x's over your x's, your y's over your y's, your equal signs need to be lined up, and your constants or your numbers without variables need to be lined up. So we need to keep things lined up, because what we're doing here is we're technically going to be adding together the two equations. So they need to be lined up. Now they don't have to be in this format. They could also be in y equals format. They could be jumbled up in any kind of way necessarily, as long as your constants are lined up, x terms, equal signs, and your y's. They just need to be lined up in order to use this method. So once they're lined up, we need to either add or subtract the equations. So it says add or subtract. You're really adding. It's just that sometimes you're doing plus and negative, which is like subtraction. Okay. We're basically trying to eliminate the variable with common coefficients. So we want to either make the x's cancel out somehow or the y's cancel out somehow by having what we call a zero pair. So for example, if one of my x's has a coefficient of a positive 4, I'm trying to make the other one have a negative 4 so that they will come out to be a zero pair and our x's will really be gone. We will then solve for the remaining variable, substitute that back in just like we did with substitution to find the opposite one. So if we find out what x is equal to, we'll plug that back into one of the originals to find out what y is equal to, and vice versa. So our first example, before we get started, got to make sure it's lined up. I have the x terms over the x terms, the y terms over the y terms, equal signs are lined up, and the constants are lined up. So when we're doing this, we want to see if anything will cancel out. So I got 4x plus negative 4x. So we're in luck. This is a zero pair. It will cancel out the x's because 4 plus negative 4 is just 0x, or 0. 9 plus 7 will give us 16y, and 5 plus 11 will give us 16. So now that my x's are gone, all I have is y left. This is why that we're doing this, because one of the variables will eliminate, and so there's only one variable left, so we can actually solve for what it's worth. So when I divide both sides by 16, I now know that y equals 1. Well, just like with substitution, when I have one of the variables, I need to plug it back in to find out the opposite variable. So I can plug that back in for y in either of the original equations. It doesn't matter. I could plug it here next to the 9, or I could plug it here next to the 7. Doesn't matter. I'll do the top one. So I've got 4x plus 9 times y equals 5. We just found out y is 1. So 4x equals 9 times 1, which is 9, equals 5. So minus 9 from both sides. And we have 4x equals negative 4. So when I divide by 4 on both sides, x equals negative 1. So although we have the x and the y, we need to actually write our final answer as an ordered pair. Putting x first, got negative 1, positive 1. That's the point where the two lines would intersect. It's the same thing we're trying to find with graphing and substitution. This is just one last method of trying to get to the same answer. We'll do one more like this where they're already lined up to go. So our x's are over each other, Y's are over each other, equal signs are lined up, and our constants are lined up. So technically we're going to be adding. We want to see if anything's going to cancel out here. I see that 10 plus negative 2 will not cancel. 10 plus negative 2 is just going to give me 8x left. But negative 3 plus positive 3, that's what's going to cancel out. That's just going to give us a 0. And 18 plus 6 is going to give us 24. So now our y's are gone, which is what we want. Elimination means it's eliminated because it's an opposite coefficient, opposite signs, and they cancel. So now we can just find out that if 8x equals 24, when I divide by 8, x is equal to 3. So now I need to go back into either one of these equations and plug that 3 in where x was. Oops, didn't mean to do that. Plug that 3 in where x is. So I could do it here, or I could do it here. These are smaller numbers, so I'll probably use the second one. So I've got negative 2 times x plus 3y equals 6. Just found out that x is equal to 3. So that's when I multiply, negative 6 plus 3y equals 6. When I add 6 to both sides, because I'm trying to find out what y is equal to, I get 3y equals 12. And when I divide by 3, I find out y is 4. So I have my values, write them as an ordered pair, 3, 4. Alright, so you've seen two examples of where they're already lined up and something already cancels. So I want you and your partner to try the next one together. Maybe you could work it on your own and then see if you guys get your same answer before you submit, or you could just do it completely independently and ask some questions if you just feel like you need help. Whatever works best. Just try number 3 and we'll see how you did.